So you know what is latch? Latch is a 1-bit device. It is used to store the data, and it consists of two output. One is the Q, another one is the Q complement. Both should be complement to each other. That is the discussion you know. Okay, and it is unclocked. There is no clock pulse. So here you can see that this is a one latch. You can see that this is the one latch in the left side and another latch in the right side. You can observe. Okay. So this is a latch using NOR gate. This is the latch using NAND gate. So latch can be designed with the help of NOR gate, or latch can be designed with the help of NAND gate also. Why we are using only NOR gate and NAND gate? Have you heard about the universal gate? Do you know about the universal gate?
Yes, sir.
We have not covered in this course because that is not given in the syllabus, but it is very important topic as per my point of my point. Universal gate is very important, and we have not covered in this course because it is not given. But universal gate is very important because with the help of NAND gate and NOR gate, we can design any logic diagram, any logic, any Boolean expression we can design only with the help of NAND gate, only with the help of NOR gate. Okay. And even we can design the XOR gate, we can design XOR gate, we can design OR gate, we can design any gate with the help of only NAND gate or only NOR gate, any logical expression. So here we are using the universal gate for designing latch and flip-flop. This is the SR latch using NOR gate, this is the SR latch using NAND gate. Okay. And here this is the Q is one output, QR is another output in both the diagram. S is for set, R is for reset. Set reset latch or set reset flip-flop we use. And here you can see that there is no clock pulse. You know, latch is the sequential circuit design, sequential logic, which consists of the feedback path. So here you can see that output is Q, that is feedback to the next or NOR gate, and we are getting the Q complement. So this is the feedback. Here also you can see the feedback, Q complement to first NOR gate. Similarly, here you can see that feedback. So it is called as cross-coupled NOR gate or cross-coupled NAND gate because they are coupled. Both the NAND gate, NAND gate are cross-coupled. Similarly, NOR gate are cross-coupled. So it is called as two cross-coupled NOR gate or two cross-coupled NAND gate. So this is a just overview about the SR latch. Now we will see for different value of S and R, what we will get. For S, if S is 0, R is 0, what will be the output? If S is 0, R is 1, what will be the output? So we will see that thing. Okay, so this is the SR latch using NAND gate. Usually, we will discuss about the NAND gate mostly in the flip-flop and latch. So this is the NAND gate. One input is S, another input is R, output is Q, another output is Q complement. Okay. Both the NAND gate are crossly coupled. One input from the another output and another input of the another NAND gate is from the one output. Please mute yourself, everyone. We are getting some disturbance. Okay. So there are two NAND gate here. One output is connected to the input of the another NAND gate, and another output is connected to the input as another NAND gate. Okay, so these are the two NAND gates closely coupled, and feedback is given here because of sequential logic circuit. But such kind of the diagram we have not seen in the combination circuit. We have not seen any feedback. That is the most important difference. Very, very important difference. And sometimes when you sit for the placement, sometimes interviewer may ask the question, what is the main difference between combination circuit and sequential circuit? What is the difference between latch and flip-flop? So such kind of the questions may ask in the job placement interview also. Okay, so far we have seen this is the logic diagram of SR latch. Now we will see if S is 0, R is 0, what will be the output? You know the truth table of the NAND gate. 0 0 0 1 1 0 1 1. You know the NAND gate 0 0 output is 1, output is 1 1 and 0. Correct? So what do we know about the NAND gate? If any input is 0 for the NAND gate, your output will be 1. If any input is 0, you can see if any input is 0 in the NAND gate, output will be 1. So here we are giving S is 0. Obviously, whatever value of this input, your output should be always 1. Correct? Are you with me at this point?
Yes, sir.
Yeah. So here in this NAND gate, similarly, if R is 0, we don't bother about what is the value of this input. If R is 0, obviously Q complement will be 1. So what are you observing here? Q is equal to 1 and Q complement is equal to also 1. So what is the observation here? It is not possible because Q and Q complement should be complemented to each other. If Q is 1, Q complement must have 0. Q complement must be 0 if Q is 1. But it is not here. When S is 0, R is 0, we are getting 1, 1 in both the outputs. That is invalid. So you can see that invalid state is written here. Correct? Are you with me? Are you following me?
Yes, sir.
Is that point clear? Why it is invalid state? Now come to the second point. If S is 0, R is 1. If S is 0, R is 1. Okay, you know, if any input of the NAND gate is 0, output is 1. Correct? So if this is 0, it will always 1. It will always 1. Okay, so this Q is 1, it means this input is also 1. If both the inputs of NAND gate are 1, what is the output? 0. Please respond me. If both the inputs are 1, output is 0. Is that fine? If S is 0, R is 1, S is 0, output will always 1. It doesn't matter what is the value of this input. It doesn't matter. If output is 1, Q is 1, so this is the input for the next NAND gate, another NAND gate. So both inputs are 1, 1, output will be 0. So for 0, 1, output is 1 here. This is the Q is the main output. Q is written here, it is 1. So now if we take another case, if S is 1, R is 0, you tell me what will be the output. If S is 1, R is 0, what will be the output? You tell me. How can we observe?
0.
0, sir.
Q complement is 1. Directly we can observe it because it depends on the value of input at this point. Then we can say that what will be the output value. But here we can conclude that if one input is 0, output will be definitely 1. Okay, so this is 1 and this input is 1. Obviously we will get 0. Okay, so for 1, 0, S is 1, R is 0, we are getting 0 here. If we talk about the last state, that is S is 1, R is 1. Okay, if S is 1, R is 1, what is the output? It is little difficult, not too much, but it is somehow different from the other conditions because here if we consider 0, we will get 1. Here if we consider 1, we will get 0. Same here. So we don't know what is the input at this point. We don't know. What should we consider here? So how we consider it? We know only 1, but if one input of NAND gate is 1, we can't conclude that what will be the output. We can't conclude because if it is 1, it will become 0. If it is 1, it will become 0. So what can we do? What can we do? We just consider Q equal to 0 as a previous state. Q equal to 0 as the old state. We consider it. Okay. So initially we consider Q equal to 0. So this input will become 0. So this is our assumption. We can take 1 also. If this is 0, it is input is 0. If this input is 0, Q bar will become 1. And this is 1. So this satisfying the 1, 1. Both the inputs are 1. Output will become 0. Correct? So this is again 0. Output is 1. This is 1. So it is satisfying the condition. So what is happening here? If previously we consider input as 0, now in the current state, previously we consider the output as 0. Now in this state also output is 0. This is previously 0. Now it is also 0. So output is nothing but the previous state. If we consider 1 here, you will get the 1 in the next state. So in the 1, 1, you will get the previous state. Or it means there is no change in the output. If previous output is 0, next output will also be 0. If previous output is 1, next output will also be 1. Is that clear?
Sir, can you
Or do you
explain
have
one
any
second,
doubt?
sir?
Okay. So our inputs are 1, 1. In the first time, we can't observe, we can't identify what will be the value of Q and what will be the value of Q complement. We can't observe that. Just we observe. In such case, what we can do, we just assume that input previous state. Okay, I will do in this manner. Q old or Q new. Okay, two outputs like that. Old output is, consider old output is 1. Okay, now this time I take 1. Old output is 1. So this is the Q old, previous output is 1, because it is feedback. We are taking the past value of the output. Correct? We are taking the past value of the output and we are observing that what is the new value of the output. Based on the past value of the output, what we are achieving the new value of the output. That is the point. If Q equal to 1, this input is 1. For both the input of the 1, output Q complement, it is 0. If one input is 0, output is 1 again. So new value is 1. Okay? If we take 0 here, take 0 here as an old value, so it is 0 and Q complement is 1 and this will become 1 and you will get 0 again. So what is happening? There is no change. Whatever value are the previous value, that is the new value. So for 1 month, if S is 1, R is 1, current state is as a previous state, or this is also called as no change in the state. State means output. What is output state? Either 1 or 0. Is it clear now?
Yes, sir.
So in such kind of the diagram, we need to take one assumption. We need to consider one assumption. If past value is this, so what we are getting the new value. Then we can conclude that what are we getting. Okay. If sometimes what happens, you are taking 1 in the assumption, you are getting 1 in the second time, I mean the next value. If you are taking 0, in such case also you are getting the 1. So instead of the previous state, we can write 1. Because in the both cases we are getting the 1. Correct? But here, previous value is 1, current next value is also 1. Previous value, if previous value is 0, next value is again 0. So there is no change in the previous state. So that is why it is called as previous state, or no change in the output.